Good day everyone. Today we are going to talk about circular motion. When we say circular motion, this is a motion that travels on a circular path because the word itself circular or circle. And then this motion comprises of both uniform, so we don't have acceleration, and also non-uniform, which has an acceleration. Then in order to illustrate what circular motion is, suppose we have this diagram right here. As you can see, this blue hidden lines indicate the circular path that is that or where our object colored in black travels. So this would be our object traveling on a circular motion, and then of course it has angular velocity. It displaces a certain angle. So as you can see here, let's say the next position of our object will be located here. So dito na yung next position ng object natin. Therefore, on that particular position, it moves at a or it displaces at a certain angle theta, diba? And then it also has a distance kasi ito is an angular displacement theta, and then of course it has a distance. So this distance right here, the arc, is known as S. And then remember in your mathematics subject that the distance S, or the arc length, is just equal to the radius. So let's say this is R cos a radius times the angular displacement theta. So ganun lang yung circular motion natin. Meron tayong angular displacement kasi nagmo-moving object natin, and then lastly this red vector here, this red arrow indicates its direction. So direction of its movement, kasi nagmo-move siya parallel and then nag-change siya at every point along this circular path. Kasi kapag hindi na siya nagmo-move along the circular path, if it goes along this direction, this perpendicular direction, then it will derail, or hindi na siya mag-follow nitong circular path na to. It will moves on a straight line. So magiging rectilinear motion na siya. So next, let's go to the useful equations for circular motion. So first we have angular velocity. Let's say this object displays at a certain angle. So as what I have told you a while ago. So now ito na yung object niya. Position ng object niya, dito na siya. Of course, we have here an angle of theta. And then since we talk about angular velocity, therefore this is the rate of change of your angular displacement. So we'll just denote this one as this, itong W, and then this is equal to the rate of change of your theta. So rate of change of your angular displacement all over the rate of change in time, or in short, you can just simply write this as theta over time. So this would be our angular velocity. How about our linear velocity? Linear velocity pertains about the distance, the circular distance traveled by our object. So this would be our arc length, the S. Therefore, we already have a displacement. So velocity, abbreviated as V, is equal to the displacement, so delta S, which is our arc length for circular motion all over the change in time. And what is this? Or you can just simply write this as S all over time. And as what I've told you in the previous section, that S is equal to R theta all over time. And from equation 1, or from equation A, we know that theta over t is just equal to the angular velocity. Therefore, we can acquire the equation for our linear velocity in terms of angular velocity. So this is equal to RW. So V, the linear velocity, is just equal to the product of our radius and the angular velocity. Okay, so let's try the next equations, or other equations. We have period and frequency. So kapag sinasabi pong period class, this is the time taken by a particle. So time taken by a particle to complete one revolution. So we can say that we can denote this as letter T. So time. How about frequency? Frequency of revolution of a particle is the number of revolutions made in 1 second. So we can denote this as letter N. So for frequency, it would be, say, N is equal to the number of revolutions. So we have revolution per time. And then how about our period? Period defines the time taken by the particle to complete one revolution. Therefore, this is time per revolution. And then note, if it is in radians, we can say that this is equal to time per how many revolutions in one full circle, or how many revolutions in one in radians. So this is equal to 2 pi, kasi 2 pi radian is equals to 1 revolution. And we can also denote N as 2 pi per time. In other books, or in other term, they state this as cycle. This is cycle per time, like hertz. Hertz is a unit of frequency, yung sinasabi natin na hertz. So therefore, the relationship that exists between period and frequency is that frequency is inversely proportional to our period, or N is just equal to 1 over T. 1 over T. So ito, inverse sila, yung period at saka frequency. Next, let's go to the normal acceleration. So as you can see right here on this figure, let's say we have an object subject to a circular motion. So this is the initial position of our object. Initial position, and then it travels from this position to the second position, or we can denote this as the final position. So here we can say that the normal acceleration is the acceleration pala to class directed towards the center of rotation. Ito, this is the axis of rotation. So this is the acceleration directed towards the axis of rotation. So, and from the previous na mga topics, we know that it's normal acceleration is just the velocity component, or the velocity that is directed towards the axis. So ito yung velocity, rate of change of that velocity per unit of time. so ano yung acceleration natin dito? So our velocity at the initial, kasi delta v ito eh. So we have v final minus v initial all over time. Then our v final, as you can see here, ito yung component natin sa ating v final, kasi hindi itong v, ito lang isang component na directed towards the axis. So we have v sine theta. So we have v final equals v sine theta minus ano yung vi natin, initial velocity that is directed towards the axis. Of course, this one, v equals 0. So therefore, v sine theta 0. Then we all know that the velocity, and delta v pala ito. So delta v na ito, delta v nito v final, kasi may 0 na, which is the initial velocity. And then we all know that if this sine theta is very small, or we just assume that this the displacement, the angular displacement theta is very small, that the y component of our velocity really directed towards the axis, meaning this one will come up here na magiging align na siya sa axis mo. So therefore, we can just assume that the value of our sine theta is just equal to theta. Kasi in a small amount, magiging equal sila yung value ng sine theta at saka theta mo. Therefore, our normal acceleration AN is just equal to v theta all over time. So from the previous, from here, jump up din dito. And then, recall that from the previous section, we know that we know that this theta over t is just equal to the angular velocity. So this is VW. So VW. And in terms of linear velocity, we know that the linear velocity is equal to V. This is equal to RW. Therefore, our W here, W is just equal to the linear velocity, V over R. Then substitute this to our equation. So we now have velocity times velocity over R. Therefore, it is equal to the square of velocity all over the radius of your circular path. So this would be our normal acceleration. This is equal to V squared all over R. So, ganun lang class. Next, let's go to the angular or tangential acceleration. So, pag sinasabing angular or tangential acceleration, this is the acceleration perpendicular to your axis. So, ito yung axis natin. Unlike normal acceleration na directed towards the axis, yung tangential natin is perpendicular. So, dito siya nag-act yung tangential acceleration natin, abbreviated by A sub t. So, A sub t natin is just A sub t is just the rate, is just equal to the rate of change of your linear velocity with respect to time. Then, or in other terms, we can also write this as a function of your radius and the rate of change of your angular velocity per unit time. Kasi perpendicular na siya eh. So therefore, there is an effect of your angular tangential acceleration with your angular acceleration. Kasi there are times that your angular displacement or your angular velocity will change. So that rate of change is equivalent to your angular acceleration. So therefore, this d theta over dt pala is just equal to your angular acceleration denoted by alpha. Kasi mag-change din yung angular velocity mo. So here, we can say that the tangential velocity is just equal to r alpha, wherein alpha is equal to the rate of change of your angular velocity, w all over dt squared pala dito, w all over time. So w over t is your alpha. So you can just write this one as r w over t. So ganun lang. We're in our theta here, or in terms of theta, you have r, wherein rw is theta over t, so r theta over t squared, ganun. But yung tatandaan mo lang sa tangential acceleration, this is just the product of your radius times the angular acceleration alpha, or tangential acceleration. Angular acceleration muna tayo, kasi yung tangential acceleration is meron na siyang measurement, kasi in terms of r na siya. So next, let's go to centripetal and centrifugal force. So these are forces that can be applied for a circular motion that is uniform in nature. So dito, uniform motion. Meaning, it doesn't have any tangential acceleration. Kasi di ba, uniform motion meaning the velocity at a certain point along the circular path is constant. Therefore, we only have normal acceleration. We don't have any tangential acceleration. And then it states here that this is opposite forces act along the same line directed towards the center of rotation. So if you have a body here in black, or you have an object, the force that pulls him towards the axis natin, is your centripetal force. Centripetal force. Whereas the force that pulls the object away from the axis is your centrifugal. So F centrifugal. And therefore, by summation of forces along the axis, we can say that the centripetal force is just equal to the centrifugal force. But, take note, but opposite direction. But opposite direction. Therefore, we can say that this is an action and reaction forces. Kasi, ano yung reaction ng centripetal force? Of course, centrifugal force. Kasi kapag walang centrifugal force, of course, yung object natin is hindi na siya mag-follow ng circular path kasi mapupull in siya towards the axis due to the centripetal force. That's why we need a reaction force na nag-opposite or nag-counteract ng ating centripetal force in order to keep the object on the circular path. So, ganun lang. So, yung centripetal and centrifugal motion natin, both are the same in terms of its magnitude, but differ on its direction. So, here, we have, or we are going to derive the formula on solving for the centripetal or centrifugal force, their magnitudes. So, let's have first the normal acceleration. So, recall that our normal acceleration, a sub n, is just equal to the square of the velocity, the linear velocity, over the radius of the circular path. So, you can see here, this is FC, centripetal, and then I abbreviate FF for centrifugal. Ganun lang. Then, for a centripetal or centrifugal force, of course, recall that the definition of force is just the mass times acceleration. So, acceleration. Mass times acceleration. So, therefore, of course, our object here on this black circle has a mass m. And what is its acceleration in terms of centripetal and centrifugal force? Of course, since uniform man ito, uniform, therefore, our main acceleration that influence centripetal and centrifugal force is just the normal acceleration. So, this is mass times a sub n. And what is our a sub n? That is equal to the square of your linear velocity all over r. Therefore, this is an expression in solving the centripetal or centrifugal force of a certain body. And it does not end here. How about, let's say we have this fixed axis, and then you have a certain object that is rotating here, and then meron kang rope. So therefore, your rope also exerts a tensile force away from this one, away from the object. So, kasi it keeps the object from throwing away the fixed axis. So therefore, the tension here, the opposite or the reaction force for tension is your centrifugal force, FF na. And for FF, in order to solve for FF, F of F is equal to mv squared over r. Kasi centrifugal and centripetal force has the same formula, but they have different directions. So, yun yung nag-counteract natin. Yun yung parang definition natin ng ating centripetal and centrifugal force. So, in order to visualize this, but before our examples pala, meron din tayong tinatawag na angular or tangential acceleration so that we can find the tangential force. So, di ba recall? So, meaning ito yung tangential force natin. Tangential force. And this is our centripetal force. So, our tangential force is tangent to the circle, the circular path. So, we have here tangential acceleration. A sub t is just equal to the radius times the alpha, or the rate of change of your angular velocity. And then again, our tangential force F is equal to the mass of the object times its acceleration. And what is its acceleration? Is equal to the tangential acceleration. So we have, kasi tangential force to, so we have m times a of t. And what's a of t? That is equal to m r alpha. So this would be the expression of your tangential force. Therefore, you already have centripetal force and tangential force. Then we can solve the reaction force of our object relative to the fixed axis. So by using Pythagorean identities, we can get the equation for the reaction force, which is the square root of the sum of the squares of your centrifugal force and your tangential force. So yan lang yung parang relationship nila. Or this, we can also solve for the okay, dito na pala siya na part, our resultant force. So again, we can say that our F resultant, FR, kasi dito this is centripetal force, this is tangential force, and our resultant is here, FR. This is just the square root of the sum of the squares of the centripetal force and the tangential force here. And from this equation, we can also derive the total acceleration for the object, because FR is just m a t na lang tayo, t na total, or AR, or the total acceleration, which is equal to the square root of m squared. Then yung c natin is normal acceleration, an squared, plus m squared. Yung ft natin is at squared. So therefore, if you're going to multiply by 1 over m, ito yung mas, makakancel to. Of course, makancel tong dalawa kasi if we extract this outside, it's just m na lang. So makancel it. That's why our total acceleration is equal to the square root of the sum of the squares of the normal acceleration and the tangential acceleration. So both force and their corresponding accelerations follows the same format of their vectors. So here, ito yung tatatandaan nyo na mga equations for circular motion. Then, to visualize that, let's have an example so that you will be able to learn how to solve problems involving centripetal and centrifugal force. Let's say we have here sample problem 1. It states that the one end of a string of length 0.64 meters is attached to a bucket. So ito yung bucket natin. As you can see in the figure, bucket containing water, and the bucket is rotated about the other end in a vertical circle. Ito yung path natin, circular motion. Find the minimum speed with which it can be rotated without spilling the water at the highest point. How many revolutions per minute it is making? So, dalawa yung requirements natin. So, let's write first the requirements. So, we are required to solve the minimum speed. Minimum speed natin in terms of dimension. So, we have the linear speed, v. And then, next is how many revolutions per minute it is making. So, we can write or denote this as our angular speed, w. So, solution. Solving this, we know that this force here, the force that is directed downward, since may water tayo, then ina-assume natin na hindi siya ma-spill during rotation. So meaning you just equate or make an equilibrium force, or imo siya make a reaction force of your weight, kasi the weight of the water is just the mass times the gravity, mg. And then, you're going to look for a reaction force. Ano yung reaction force? Ano nga yung tawag sa force that is away from your axis? This is your centrifugal force. So FF. Therefore, if we sum up summation of forces along horizontal, kasi diba horizontal man ito, I mean vertical pala. This is vertical. So the summation forces along vertical should be equal to 0 in order to achieve this, that the water should not be spilled out during rotation at the highest point. So therefore, summation force equal to 0. So we know here that your centripetal force is just equal to your weight, or W, the weight of your bucket or your water. Kasi if we transpose it on the other side, so we have FF minus W is equals to 0. Therefore, we achieve the equilibrium position. And then, after this, we recall that our centripetal force is just the mass of the object, which is the mass of the water, times its velocity all over the radius of our circular path, which is also equal to the weight of your water. What is the weight of our water? It's just the product of your mass of water times the acceleration due to gravity. Since they have both mass on both sides of the equation, so we can cancel this one out. Since we're going to look for the velocity, so matitira yung velocity, v squared is equals to multiplied r to g, so we have gr. Then square both sides, square natin. What's left is velocity is equals to the square root of the product of acceleration due to gravity times radius. Then we plug in the values. So i-plug in natin yung values. So we have, this is equal to the square root of 9.81 times our radius. The radius is ito, 0.64 meters. So multiplied by 0.64 meters. Then if you have calculators there, so that would be equal to, sorry, so I have here my calculator. Square root of 9.81 times 0.64. The answer is approximately equal to, this is approximately equal to 2.51. So 2.51 meters per second. So this would be the minimum speed that we required, or that is needed, in order to avoid spilling of the water at the highest point. So let's try to solve the other one, the other requirements. So for the next requirement, you are tasked to solve for the angular velocity. Kasi sabi to, yung angular velocity, yung measurement ng angular velocity is in revolution per minute. In your higher subject, it is denoted as RPM, rev per minute. So sabi dito, revolutions per minute. Kapag sinasabi revolutions per minute, this pertains to your angular velocity. So W, we know that W is equal to the angular displacement all over time. But recall that we have a relationship that exists between your velocity, linear velocity, and angular velocity. What is this? Your linear velocity is just equal to your radius times your angular velocity. Since we are given with our radius, and since we already solved for the velocity, therefore we can rewrite W, or the angular velocity, is equals to your linear velocity all over the radius. And then plug in the values. We get earlier a velocity of 2.51 approximately, divided by the radius of 0.64. Now the answer for our angular speed, or revolution per minute, is 251 all over 0.64. This is equal to 3.92. So 3.921875. Again, anong units nito? This is, kasi diba yung sa numerator is meter per second, meron tayo ditong meter, therefore a certain unit, which is radian, kasi meter divided by meter is makancel out, so that is radian per second. Then, sabi dito, revolutions per minute man, so we convert. So, sa isang revolution, kasi diba isang revolution is a whole circle. And what is the equivalent of a whole circle in radians? That is equal to 2 pi radian. So, 2 pi radian pala is equal to 1 revolution. Since may second tayo, and then yung hinahanap is minute, therefore, we need to convert second into minute. So, we know that 60 seconds is equal to 1 minute. Then, simplify everything. We have an approximate value of our angular speed, which is equal to 60 over 2 pi times 3.92. The resulting answer is 37, so approximately 37.45 rev per minute, or RPM. This would be our final answer for our angular speed. So next, let's jump to the next question. Sabi dito, a string of length 3 meters can withstand a maximum weight of 10 kilogram weight. A body of mass 5 kilogram is tied to it and whirled round in a horizontal plane. Calculate the possible maximum number of revolutions per minute. So, our requirements here is what? Sabi dito, the maximum number of revolutions per minute. So, again class, pag sinasabing revolutions per minute, this pertains to your angular speed. This is W in RPM. RPM. Or rev per a minute. So, in order to understand the problem, let's illustrate. So, let's illustrate. So, sabi dito, meron kang string na length of 3 meters. So, I have here a fixed axis. Kasi, inaano mo. Then, we have a radius which is equal to the length of our string equal to 3 meters. Then, sabi niya, it can withstand a maximum weight of 10 kilogram weight. So, therefore, it can stand a tension force. So, tension force kasi maka-stand daw siya, meaning hindi siya ma-break apart or maputol. So therefore it's a tensile force, meaning it has a maximum tension of 10 kilogram weight. So 10 kgf. Pag sinasabing kilogram weight, that is in kilogram force. Then a body of mass 5 kilogram is tied to it. So dito meron tayong body, it has a mass of 5 kilograms. So 5 kilogram. Then it's tied to it around the horizontal plane. So calculate the possible angular speed. So you can see here, when it rotates, so kapag na-rotate na to in a circular path, of course, hindi siya matatangay or hindi siya mag-move away from the circular path kasi meron kang string na nakatali. So meron kang tension along the center of your circular path. But you also have a reaction force. And what is this reaction force? Okay, you have a force outward or away from the central axis. This is known as the centrifugal force. So by summation of forces along that line, so we have solution. If we sum the forces along that line, we can say summation forces along the axis is equals to 0. That's why we can say that the centrifugal force is just equal to the tension of your string. That is the same as the tension of your string. And what is your centrifugal force? Centrifugal force is your mass of the object times the square of its velocity all over r, which is equal to the tension of the string. And take note that tension of our string is in kilogram force. We can convert it into newtons. So let's say 10 kilogram force. So in your conversion unit, you have 1 kilogram force is equals to 9.81 newtons. Then we need to look first for our velocity, kasi if we already know the velocity, we can link this to our angular acceleration, angular velocity, which is our requirement. So therefore, arrange the equation so that v is only left on the left side. So we have v squared is equals to r over m times 10 times 9.81. So this 9.81 is from the conversion unit. Kasi makasalaan ito man-Newton ito siya. So square root both sides. Take the square root both sides. We have our linear velocity equal to the square root of, what is our radius? Our radius is 3 meters. So 3. How about the mass? The mass of our body is 5 kilograms. So 5 times 10. Yung 10 natin is the tension. Then, kina-convert mo into newtons. So, we now have a velocity, a linear velocity of, so 3 over 5 times 10 times 9.81. So, we have an approximate value of our linear velocity equal to 7.67 meter per second. Then we all know that the linear velocity is equal to the radius times the angular speed. So therefore our angular speed is equal to the velocity all over r. And since we have a value for velocity which is approximately equal to 6.67 or 7.67 divided by our radius 3 meters, we have an approximate value of our angular speed in terms of radian muna yan ha, depending on RPM. So we have approximately 2.56 radian per second. Bakit second? Kasi yung velocity natin dito is in second. So since yung hinahanap niya is in revolution per minute, so we need to convert that one. So i-convert natin yan. So we have 2.56 radian per minute, per second. So we all know that in one revolution or one full turn of the circle, this is equivalent to 2 pi radian. So take note that one, class. Then we also know that for 60 seconds, that is equal to 1 minute. Then simplify natin. 2.56 times 60 divided by 2 pi. We have a final answer in terms of RPM. This is equal to 24.45 revolution per minute, or RPM. So this would be our final answer. So let's go to the last question for a circular motion. Let's say we have a crank QB 1.5 inch long is turning clockwise about a fixed axis Q. The angular speed of QB at a given instant is 2 radian second, and the angular acceleration is 1.5 radian per square second. Compute the tangential and normal components of the acceleration of B, or the crank B. So we need to illustrate this one first, and this question came from the machine element question. So you can meet this in your higher na mga subjects, in your higher subject. So here, let's draw crank QB. So pag sinasabing crank, this is a certain arm that rotates on a fixed axis. So axis natin Q, yan yung fixed axis natin. So yung B pala natin, the certain body or a certain part of our crank B is rotating on a circular path. So therefore, we also have a measurement for QB. QB is equal to 1.5 inches. So therefore, please be aware of the measurement or the unit of your radius, QB. And then we also have another given. Given natin is 2 radian per second. Ano ba to? This is our angular speed, so W, which is equal to 2 rad per second. Next, we also have angular acceleration. So this is your alpha. Alpha is equals to 1.5 radian per square second. What is our requirement? So we are required to solve for the tangential and normal components of the acceleration of b. So we can say this is an and at. So let's solve. This is our solution. Let's solve first the normal acceleration. We all know that normal acceleration is equal to the square of your linear velocity all over r. And we all know that your linear velocity is just equal to rw squared all over r, or equal to r squared wr over r. Therefore equal yan siya sa rw squared, kasi makancel yung r sa ibaba, isa na lang matitira sa itaas. And since we are given with our radius, therefore we can simply write this as radius natin is 1.5 inches. Let's convert it into centimeters lang muna, kasi hindi man lang dito nilagay kung ano yung dapat unit ng ating answer, or you can just stick with the inches. So let's say 1.5 inches multiplied by angular speed. So this is 2 radians per second, then squared. So we have a final answer of 1.5 times 4, which is equals to 6 inches. So this is 6 inches per second squared. So diba? Yan yung normal acceleration natin, 6 inches per square second. How about our tangential acceleration? So recall again the formula for tangential acceleration. So we know that the tangential acceleration is just equal to the radius times the angular acceleration, which is alpha. So since alpha is already given, so plug in the value. We have 1.5 inches as your radius. Angular acceleration is 1.5 radian per second square. Therefore the value of our tangential acceleration is just equal to 1.5 times 1.5, which is equal to 2.25. So therefore this is 2.25 inches per square second. So this is now our tangential acceleration.